Hello everyone, welcome back to Study Room. So in this video, we are going to learn more in detail about vibration and three most important characteristics of sound, that is amplitude, frequency and pitch. We are also going to learn about loudness and how is loudness related to amplitude. So let's get started. Now, oscillatory motion. This to and fro movement of any object is known as vibration. Now, this motion is also called as oscillatory motion. That means oscillatory motion is nothing but a to and fro movement of an object. As we can see here in the case of swing, there is a to and fro movement of the swing. Similarly, this lady sitting on the rocking chair, there is some kind of to and fro movement. So, this is known as nothing but oscillatory movement. Simple enough, easy to remember. So, again, the to and fro motion of an object is known as oscillatory motion. Now, there are multiple examples of oscillatory motion, such as vibrating strings, and as we saw in the case of swinging of the swing, right? So, let's move on. Now, frequency. What exactly do you understand by frequency? So, the number of oscillations per second is called the frequency of oscillation. So, what exactly is this frequency? How many ever to or fro movement an object makes per second in 1 second is called the frequency of oscillation. Very simple definition. What is frequency? The number of oscillations per second is called frequency of oscillation. Now, this frequency is expressed in hertz. Its symbol is this, it's Hz. So, the unit is hertz. Now, a frequency of 1 hertz is one oscillation per second. That means it's making one to or fro movement. That is one oscillation per second. So as you can see in this image, is that if a signal is a low frequency signal, it will make less number of oscillations, while here in the same given time period, it will make more number of oscillations. That means it will be a high frequency signal, right? Simple enough. Let's move on now. Now let's answer this question. If an object oscillates 20 times in 1 second, what would its frequency be? In the previous slide, we saw that if it oscillates once, then the frequency is 1 hertz. So if it is oscillating 20 times, then what will be the frequency? Cross multiplying, we get that the frequency will be 20 hertz. Simple enough, right? So let's move on. Now amplitude. We already saw about one characteristics of sound, and let's move on to amplitude. Now, what is the definition of amplitude? Amplitude is the maximum displacement or distance moved by a point on a vibrating body or wave measured from its equilibrium. So, as you can see, if these are the waves, then maximum displacement of the wave, this is known as amplitude. Some signals may be having a higher amplitude, that means large distance covered, and some may be having a lower amplitude, right? Let's move on. Now let's brainstorm this question. You can recognize many familiar sounds without seeing the objects producing them. How is that possible? What factors make them different? What are those factors that are enabling us to rectify or recognize these sounds without actually seeing them? So, it is because of the characteristics of the sound. characteristics of the sound. These are the factors that make it makes us it makes it possible to recognize the sound. So these characteristics are frequency and amplitude. Different sounds have different frequency and amplitude, and these are the characteristics which make them different from one another, which makes one sound different from the other, right? So let's move on. Now let's perform this activity to show the amplitude of vibration. Now what do? You take a metal tumbler and a tablespoon. Now, what do? You strike the rim of the metal tumbler and listen to the sound. Now, what do? You bang the metal spoon on the tumbler. You will hear a sound which is different. Now, you take a thermocol ball and touch it near the rim of the metal tumbler and bang it again with the metal spoon as it is shown in the figure over here. So what you have to observe is that the thermocol ball will get displaced to a certain extent. So here we see that the displacement of the ball is a measure of the amplitude of vibration. How much ever distance it's traveling, that will give the amplitude of the vibration. The amplitudes of vibration on the tumbler are larger when it strikes a little harder. If when we struck it on the rim, the amplitude was less, and when we banged it in the middle, the amplitude became higher, right? Now, what is loudness and what does loudness depend on? So, the loudness of the sound depends on its amplitude. Am I right? So, when the amplitude of vibration is large, the sound produced is loud, and vice versa. That means if the amplitude of vibration is small, then the sound produced will be low, it won't be very loud. So, we can say that it is proportional to the square of the amplitude of the vibration producing the sound, right? We can say that. So we can write that loudness is proportional to the square of the amplitude. So if, for example, if the amplitude is 2, then the loudness corresponding to it will become the square of this, which is 4. Very simple. Now, the loudness is expressed in a unit called decibel, and its symbol is dB, as shown over here. Let's move on. Now, compare the sound of a baby with that of an adult. Is there any difference? Yes, there is a clear difference. We come to know when a baby cries. So, why does it happen? It happens because of the different levels of frequency. It is because of the different levels of frequency, right? So the sound of the baby may be high pitched and that of an adult may be low pitched. Clear? Now, what is pitch? I kept saying about pitch, low pitch and high pitch. But what is it exactly? The frequency determines the shrillness or pitch of the sound. So, pitch is nothing but the shrillness of the sound. If the frequency of the vibration is higher, we say that the sound is shrill or has a high pitch. If the frequency of vibration is lower, we say that the sound has a lower pitch. For example, We see in the case of a drum, the drum vibrates in a low pitched sound. That means it has low frequency and therefore a low pitched sound. But on the other hand, if you blow a whistle, it has a high frequency. That's why it has a higher pitch. Clear? Now let's compare the sound or the roar of the lion to the sound of the bird. What happens here that the bird has a higher frequency and therefore a higher pitch, while in the case of lion it has a lower pitch and lower frequency. But the sound of a roar of a lion is very loud as compared to the bird. So we can say that loudness and pitch are two different characteristics, right? Let's move on. Now, did you know that usually the voice of a woman has a higher frequency than that of a man, and therefore a woman's voice is called high pitched and a man's voice is called low pitched? Clear? Now, audible and inaudible sounds. Sounds of frequencies less than 20 vibration, that is 20 hertz, cannot be detected by the human ear. And because they cannot be detected, they are inaudible. And on the higher side as well, above 20 kilohertz, humans cannot hear. That means it makes it inaudible. Thus, for the human ear, the range of audible frequencies is roughly from 20 to 20,000 hertz. A frequency higher than 20,000 and a frequency lower than 20 hertz cannot be heard by humans, right? So, some animals can hear sounds of frequency higher than 20,000 hertz. Now, this is a fun fact. Dogs have this ability. Dogs can hear the frequency, they are able to detect the frequency about 20,000 hertz. So, now for this, what does the policeman do? The police use high frequency whistles that is above 20,000 hertz, which dogs can hear but humans cannot. There are some dogs which are used for security purposes, and for them, these whistles are used. Very simple. Now, another fun fact, the ultrasound equipment, familiar to us for investigating and tracking medical problems, works at frequency higher than 20,000 hertz. So, for the frequency that are above 20,000 hertz, there are many uses for this. They are proved to be very beneficial to us because they are used for investigating and tracking medical problems. So, let's continue. So this was all for this video. We learned the definition of amplitude, frequency, pitch, how are these factors affecting sound, what is loudness, how is it related to amplitude, and we saw some fun facts about the frequencies. And we also learned that the range from which the humans can hear the frequency is 20 to 20,000 hertz. Okay, so we'll connect next time on Study Room. Till then, thank you and see you next time.